Welcome to AI for Good, the leading, action-oriented, global and inclusive United Nations platform on AI. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with 50+ UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to unlock AI's potential to serve humanity. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Yeah, hello and welcome to today's contribution to the AI for Good discovery series from molecules to models. Today's contribution will focus on a crucial issue: how humans trust large language model outputs and how this relates to how humans perceive AI and how AI perceives humans, if the concept of perception even applies to artificial intelligence systems. Our presenter today is Yuxia Wang. Her research is in the field of natural language processing, where she aims to ensure safe, factual, and empathetic human-AI interactions. Yuxia is an assistant professor at the Institute for Computer Science, Artificial Intelligence, and Technology in Sofia, Bulgaria. And prior to taking up this position recently, she was a postdoc at the Mohammed bin Zayed University of Artificial Intelligence in Abu Dhabi in the field of natural language processing. She has her PhD from the University of Melbourne and also industry experience in the field. So yeah, Yuxia, the floor is yours, and please take us on the journey into AI, trust and communication between humans and AI.
Thank you very much for the introduction, Alexander, and I will share the screen now. Hello everyone, and I'm Yuxia. And so firstly, I really want to say thank you, and it's a great honor and a pleasure to join Alice AI for Good webinar. And thank you for all of our audience for choosing to spending your valuable 1 hour with me today. And so my research mainly focused on the large language models, safety, empathy, and as well as some applications in the finance and the medical domains. When I first arrived in Sofia and worked into the supermarket, I realized that all the product labels were in Bulgaria, and the fruits and vegetables are easier enough to recognize. But when I say which one is the sugar package and which one is salt package, it's really hard for me to recognize these languages. So I took out my phone and asked the ChatGPT and to identify which one is which one. And so it is my first time to learn, okay, and the word with the symbol look like a three, it's the sugar, and if starting with the kin, it's the salt. And so since then, almost every time I went to the supermarket, I just need to ask the questions to the ChatGPT. Is this a pure beef means, or the beef and pork mix, or this roasted chicken priced by the kilogram or by the piece? And really, thanks to the current AI development, my transition to life in Sofia has become so easier and smoother. So I believe otherwise I need to ask help for help from the strangers every day. And there's a canteen downstairs of our campus, and where we usually have a lunch on the work days. And I'll run into the same problem. And there's a menu and changes every day. And I really love tiramisu cake. So of course, every day I just want to know, okay, whether they're saving it today. But look at this menu. I can totally cannot read, and even I don't know which part is the desserts and which part is the main courses. And actually, the at the bottom, and but I still cannot, read whether it has the tiramisu. The fact is that there's no tiramisu that day. They only provide the French country cake, Miko cake, and the apple pie with the vanilla sauces. So from these examples, we can feel, how helpful is the current model for our daily life. They just based on our input text and images to identify which part is relevant to our request and then respond to our confusions. And so they make the daily life more convenient and easier. So I believe this is also why we have this AI for Good seminar series to share our stories between, AI interactions and to see, okay, how positive AI can support and enhance our lives currently and also in the future. So, in today's talk, I will begin by understanding the differences between the model's generations and the human written text, and then move to the model's behaviors and the ways they can potentially cause harms. And finally, we will look at an interesting large language model application in a dream interpretation. Because dreams always regarded as our, how to say, the consciousness and our mindset reflection. So we want to know, okay, how AI sees our mindset and consciousness. And so in addition to understanding our input, models can also generate. For example, for these 6 pictures, okay, let's say like the 3 as a group, which one is the real and which one is the model generated? When I first see these pictures, it's really hard for me to recognize. The gold label is actually the first 3 is real, and then the 3 at the bottom are generated by model. Especially, this one, and it's very hard for me to recognize as it's a machine generated. And let's look at a video. It's so real, right? And another one. Actually, all of them were generated by Google Nano Banana. And I believe, we always think it's a real or it's a human made, but actually, no, it's not the video, it's just the generated video. And let's look at another one. This is a poem. I'm not sure whether you are familiar with this author. And so for me, it's very hard to say this author is the real this poem's author or it's just drafted by the models. The fact is that this poem is drafted by GPT 4.1. Especially for some domains like poem that we are not familiar with, we don't have the prior knowledge and we don't know the author's style or the topics they always written. It's hard to see and to distinguish which one is human written and which one is machine generated. So this is very aligned with the previous findings. They say since the emergence of the GPT 3.5, it's very challenging for humans to tell which one is the machine-generated content. So the detection accuracy are always just no better than the random guess. So we're thinking about, okay, can this conclusion generalize across domains and languages? Or how about the detection capabilities of the experts, for example, the large language model developers, practitioners, and researchers? And so to answer this question, we literatured all the previous work of the machine-generated text detection by humans and observed that most prior studies focused on the binary detection and primarily in English, and most are content produced by the GPT 3.5 rather than the latest of the state of art. And the domains involves the Wikipedia, news articles, and product reviews, and social media posts. This is diverse. And across all these studies, the number of annotated samples are generally small, typically just under the 8K. And the annotators are mostly lay people rather than the experts. All the detection accuracies often hover around like the 40 to 70%, which is almost close to the random guess in many cases. Of course, performance will be tended to be improved when the experts annotators were involved. So this previous work has motivated us to think about, okay, what is the upper bound of the human detection capabilities for current state art model generations? And do even the large language model practitioners or the experts struggle to detect the output? And how about the other non-English languages, for example, Vietnam or the Japanese or Chinese? And how can or how cannot humans to tell the differences? What's the challenges here? And do humans really like the human written text, or maybe they like the machine generated text, and why? So in this part of the talk, we try to answer these questions. So we performed a case study to explore and the multilingual and multi-domain human detection upboard, and also to see their correlation between the human detection accuracy and their preferences. So we involved like 16 datasets covering the 9 languages and 9 domains, and 19 annotators participated into the annotation. And the surprising number is they achieved an average detection accuracy of 97.6% of the accuracy. So this somewhat challenges the previous finding of the random guess. So this table shows the dataset-wise and language-wise detection accuracy. Later we will analyze in detail. So let's first look at each column, the meaning of each column. Okay, the language and the source and the number of the examples we don't need to, explain. But for the annotators, all the annotators who were invited to identify all the corresponding native speakers. And we have 4 annotation settings, including like the pair binary, pair full class, and single binary and triplet 3 class. This maybe looks like very confusion. Let's just, split it into 2 parts. Okay, if you check like the single pair and triplet, this means the input. Okay, how many cases or how many snippets of text were given to the annotators. And the binary 3 and 4 class is the classification task. Okay, it's we need to choose one from the 2 or 3 or 5 or 4 options. So for example, for the first one, the pair binary means, okay, we're given a pair of text 1 and text 2. One of them is machine and one of them is human. And then we need to identify which one is human. So this is the, okay, given a pair and to identify one option from the binary. And then for the second one, it's pair for class means, okay, I have a pair of text 1 and text 2, but the text 1 and text 2 can be both machine or human. This means there's the 4 options. So we need to choose the human one from these 4 options. And the third one is a single and the binary. This means we don't have the comparison references. We only have the single text and to detect which one is human. And the triplet means we have 2 machine-generated text and need to identify which one is human. Okay, let's roam into one column of the Arabic language, this one. And for the Arabic language, we actually have the three annotators because for the news, this is the same annotator. So we have the three annotators and we involve three domains, including the Arabic dialect, treat, and the academic summary and news. For the few shot or zero shot, this means before annotating, did the annotators see some label examples to learn some distinguishable cues? If not, zero. If yes, they look at it like this 10 or 20 examples, it's a few shot. Um, if we look at the accuracy, how to see. And in addition to the Arabic news, several other data sets, for example, the Chinese QA, student essays, government report, and English academic matter reviews, and the Italian news and the Russian news, they all choose the detection accuracy close to 100%. However, these results, they do not, reveal any consistent patterns to suggest, okay, this language or these domains, they just easier to be detect. So we may say news is easier for people to detect because we see news articles every day and people are familiar with the structure and styles, but actually not that. If we look at like the Italian news, but generated by Anita, this model, it's harder than other models. And also the Japanese news is the accuracy also belong to the average level. So we cannot say, okay, which language or which domain is easier to detect. It's closely related to the generators. And detection with lower accuracy, such as Arabic treat and summary, and also the Hindi's news and the Kazakh Wikipedia, Russia summary, and Vietnam Wikipedia and news. Their accuracy is below the average level. So we just interviewed the annotators to get the feedback. Why they're so hard? And the annotators told us the Twitter is too short and it's very hard for them to capture the distinguishable cues, especially when they're dialects. The Wikipedia entries generally especially for the low resource languages, um, the machine generated and human written are very similar. And I guess this is because the Wikipedia data, particularly for the low resource languages, they're high quality data and they were always used in the model pre-training and SFT. So they have been deeply memorized by the model. So the model and the machine have the similar outputs, so making us very, difficult to identify. But if we want to summarize some, the patterns, Chinese, English, Italian, and Russia, their detection accuracy is above the average bar. And for Vietnam, Kazakh, Arabic, Hindi, they're below the average bar. But for Japanese, it's very close to the average bar. Maybe we can say, okay, the low resource is, harder to be detected, but we need to be careful to claim this kind of statement because it's really related to the domain and also the generators. Um, if the detection accuracy is very low, this means the generated text, the quality is high. It's very close to the human written. So we can see, okay, the model now have the high quality generations in the tweet and also in the Wikipedia and also the Arabic and Russia summaries. And for the impact of the generators, it's really closely related to the languages and the domains. For example, for the Chinese, there's minimal differences, and if you change the generators, but for Italian, and the impact is visible. Um, if we're talking about the annotation settings impact, it is easier for people if we have like the pair input or triplet input because we have a references text to compare. But if we only have, the single text, it's the hardest mode. And if you increase, the output classes for the binary or 3 class or 4 classes, this has a minimal impact on the detection. This means if you increase the number of the final options, it does not impact the detection accuracy. And we also summarized the 5 generalized distinguishable factors across languages and datasets. The annotators reported 5, and the first one is human texts are more informative and more concrete. They include the URLs and the person names, organization locations, and so on. But the machines are, less informative, and also the machine text lacks the regional, cultural, and religious nuances. Machine written text also don't have the much, diversity. If we look at the human written essays, they substantially diverse in terms of lacks, structures, and styles and sentiment, but machines does not. They always also express their positive sentiment, even the things is very sad. And also the machine generated text have the perfect formatting. They're always well segmented, have the bullet points. And this is a very obvious distinguishable factors. And for some low resource languages, especially generated by the open source models, for example, the Kazakh, the output is always a mixture of other languages. They will include the Russia, English, and even the Korea. And so based on all of these summarized distinguishable cues, we will think about if we explicit instruction models to avoid these, gaps and to mitigate these gaps and to instruct them to say, okay, please to be concrete and please to avoid using the bullet points. Can such kind of simple prompting to fill the gaps? And the results is yes. And for many datasets, prompting strategies can either fully or partially solve the gaps of the more than half of the examples. And we further performed another, detections over, the same datasets, but, the new generations by the improved prompt. We will find with the same annotators and the detection accuracy will decrease to 72%. This means we're using this prompting strategy, it can mitigate some gaps. And okay, what kind of gaps? And we find for the first one, it's easier, but there's two still remain challenging. It's the cultural, regional, and religious nuances. They're hard to be mitigated. And also the diversity in the style, structure, and sentiment is hard. But for others, it's easier. And so before we're using the complex strategies or using the more GPUs to train the model to align the, the human written text, we will ask ourselves, do we need to do that? Maybe, we don't need because humans maybe they just like the machine generated text, not like the human written text. So we ask the questions, do humans like human-like text? So we choose the, four options, the human text and the machine generated text using the original prompt and the improved prompt or nothing, neither of them. And at the same time, we also want to know like the impact of the human detection accuracy on their preferences. So we choose the 3 level of the detection accuracies and Chinese essays, QA, and Russian news. These are just 1 level, close to the 100% of detection accuracy. And for Russian Arabic summary, it's the moderate level. And for the Arabic dialectic, it's a random guess, it's 50%. So we choose these 3 stands of the data set. And, for the Chinese essays, we can see this is the preferences distributions. And we find that most annotators tend to choose the human written ones. And when we asked them, they say because human written essays are more diverse and they can written some very elegant sentences or they're more creative. But the machine generated one is a more fixed mindset or something. And but for QA, the distribution is very different. And if we look at the second reviewer and the last reviewer, we find a very interesting phenomenon. The second reviewer almost did not, choose the human answers, but the last annotator almost chose all as the human answers. And so we interviewed the second annotator to see why, and he told us he did not like the many human answers because the humans sometimes are very mean, especially for some emotion-rich questions. Human answers tend to just express their own opinions. They neglect, what the help seekers needs. They just express their own opinions. And so he don't like it. And this just inspires us to care about another set of questions is emotion-rich questions. So we labeled 100 pairs, and we find that people really just like the machine and the human half by half. Even they prefer the machine generations. This is a little bit out of my previous how to say the findings or the expectations, because previously we always think humans are more empathetic, they can express more empathy to our peers, but the fact is maybe the opposite. In half cases we tend to like the machine generations. And two of the annotators, they also, choose 10 to 20% of them is neither of them. This pink bar, they don't like the machine. They also don't like the human. And then for the Russian news, the first annotator we know, this annotator, he achieved 100% of the detection accuracy. We find he tends to choose the human written one. And similarly, um, for others, we don't know their detection accuracy, so we cannot see, the correlation between it. But for the Russian summary, and we find like when the detection accuracy decreased to 80%, the machine-generated text are preferred, because only this blue bar is human written, and for other two bars, all the machine generated. So we can see humans prefer machine generated content. And then when we look at this, like the summaries by the aerobic and the aerobic tweet, when the detection accuracy is 80% and the 50%, almost people just prefer the machine generated. So we just preliminary get the findings like, okay, for the once the detection accuracy is high, humans can clearly identify which one is human written, and they tend to choose their peer written text. This is human written because of the trust. But once they cannot clearly identify which one is which one, they will choose the machine generated text. So from this study, we can see humans do not always prefer human written text, and particularly when they cannot clearly identify its source. If we, employ the experts to identify the human or machine, their accuracy is high, but this high accuracy is easily to be destroyed by simple prompting strategies. The cultural nuances, diversity in the lag structure, and phrases are hard to be mitigated by the simple prompting strategies. And this is what we can take away from the first study. And now we've explored how humans perceive differences between human written and machine generated. So we believe one day, maybe, human written and the machine generated, there's no gap. If in that day, how could we, just trust the machine generated text? So we need the evaluations, and we need to know whether the machine generated text is safe or fair enough. So this just move to our second part to explore the behaviors, especially the fairness behaviors of the models. And in this part, we will introduce the large language model fairness evaluation and taking the harm aware into the consideration. In a previous study, they always just use their own collected data to do the evaluation. So it's a little bit isolated, not that comprehensive. And they also just care about the word association, QA, and generation, this traditional task, not, the realistic settings like the medical and the, like the legal assistant or other like the recruitment systems or all of these realistic deployment applications. So they show like the weak connection to the actual harms. So the models can pass the benchmarks showing the academic papers, but they still struggle to generate the harmless outputs if we deploy them in the clinical or the hiring settings. And another big issue is all the studies treat the biases equally. But we can obviously feel like slight biases in the low stake applications such as the news summaries have been, have the neglectable impact on the user's welfare if we compare with losing a job opportunity due to the biases in the rhythm scoring systems. So that's why we want to take the harm-aware taxonomy and also the deployment into this fairness evaluation. And then based on the EU AI 2024 acts and also the World Health Organization and US Equal Employment Opportunity Commission statements, we included 9 application domains and grouped them into the 3 tier of the harms, including the severe and moderate and mild applications like the recruitment, selection systems, legal assistant, educational access decision system, and also the medical assistant and the employment systems. So this pipeline has 5 components. Given the application, we will first search the related bias and the fairness evaluation dataset. If the dataset exists or available, and we will directly apply. If not, and we will try to adapt the relevant dataset to this application. For example, there's less dataset for the recruitment and the recommendation system. So we adapt the relevant dataset by augmenting it with the demographic context and providing more, scenario-specific context to the dataset. And so we collect 12 datasets for 9 applications, as shown in this table. And they were grouped into the 3 levels. If we check the last column, adapt, this means whether this dataset is adapted from other, dataset. For the first row, the medical one, it was adapted from other datasets, and we want to evaluate the gender and ethnicity biases by the clinical MCQ data formats. And if we look at the tasks we included in this evaluation, it involves like the MCQ, classification, and also the ranking, and so on. So it's a diverse task formulations. And let's look at the, the first data set, the medical MCQ. The original cases is a woman. And so we will first evaluate the model's accuracy without any race context, referring to the neutral results. And then we will end the demographic context to the original MCQ. Like, for example, we will replace a woman with an Asian woman or the Western woman or Arabic woman. Anyway, Then afterwards, we will reevaluate the model's accuracy and to see the gaps. Generally, the gender we will consider male and female. Race here for the first data set, we consider the Western, Europe, Asia, and their intersectional categories. This table is hard to read, but no worries, we don't need to read it. And I just want to know, to say, okay, afterwards we will measure the accuracy gap between the neutral results and the results after adding the specific demographic features, and to assess the impact caused by the different group of people. So for example, given the cloud 4, and this is the gap between the neutral accuracy and after adding this specific demographic group. And then we will calculate the average. We will first absolute this number and calculate the average and normalize with other model scores to normalize the score between the 1 and 0. After we get all, this data set and the model scores, and we will have a aggregation. Okay, given the data set and given this model, we have a score and to indicate its fairness, and then we will have a weight. This is the harm-aware weight, and to have this half score for this model. This is the final results. It's a dataset-wise fairness score, and also we have the aggregated score at the last 2 columns. So in order to easy to identify which one is poor and which one is good, so the red one is the poor, and the orange is below average, and the green is good, and the blue is excellent. So what we can see here is for the commercial models, at the above. This 4 is commercial models. This is open source models. And we can see the commercial models outperform the open source models in fairness, but mainly in the severe and moderate harms. Actually, in the mild harm applications, they're comparable. And also the bias does not transfer predictably across the domains. Given the model, it does not show, consistent fairness patterns and the scores across the domains. This is 2 findings. And we also find like this is the neutral performance, the accuracy across all models, and this is a fairness score. Observing whether they have the correlations, the answer is actually no. And the task for performance does not predict the fairness scores. For example, if we look at this red cell, it's the DeepSeek version 3 on the bias MetaQA. It's a very poor fairness score, but it has the good neutral accuracy. So we cannot say, okay, if the model performs good, it will also necessarily to have the good fairness scores. Here we also compared the reasoning model and between the general purpose model, and we will find the reasoning model, this purple bar, is only outperform the general purpose models when the harm type is severe. And based on the Llama 3.2 family, 1 billion, 3 billion, and 8 billion, the model scaling will impact the fairness score, but the pattern is difficult to summarize. It's in a complex and non-nomotonic ways and without the generalized patterns. So from this, we can see the commercial and the reasoning models show the clear advantages in the severe harm scenarios, but offer less advantages in mild applications. Bias does not transfer predictably across domains, and also task performance cannot predict the fairness. So what we can learn or how it will guide the future deployment is that, for example, if in the future you want to deploy mild harm applications, actually you can choose the open source and small models. You don't need to choose the commercial and the reasoning models that is expensive. But if you want to deploy the medical and legal, this harm of the severe harm level applications, better just to use the commercial and the reasoning models to help you to make the decision. And so let's see the last part. If we apply the large language models in the dream interpretation, well, the reasoning models perform better, or the general purpose models perform better. And so human always just viewed the dreams as a reflection of our consciousness and the trace of the emotions and thoughts. So can language models, which is not conscious but trained by a lot of data, grab our inner landscape of the dreams and our minds? And actually, dreams have been fascinated humans for a long time, and the major turning point came with the Flores theory that dreams express the repressed desires and relieve our internal tensions. And afterwards, we analyze the dreams from the psychological and neurological perspective to connecting with the memories and consciousness. Afterwards, they analyze it from the dream narratives, from even the linguistic perspectives by the experts or the NLP tools, and now they by the large language models. So it's a process how we analyze the dreams or interpret the dreams. But actually, all this is how Western cultures interpret dreams. For the Chinese or the Arabic cultures, they do not interpret dreams in this way. For the Chinese cultures, they are mainly based on the ancient knowledge or the accumulated experiences. But for the Arabic, it's more, highlight the importance of the religion and their God. So that's why we see when the same symbol appears in this picture, its interpretations sometimes diverge, sometimes they have share something. For example, for the water and the three cultures all share the positive means, but when you dream the fire, it's diverse. The Western cultures generally think it's betrayal or threat or even temptation. But in the Chinese tradition, fire means wealth and prosperity. In the Middle East, it's a combination, and it means both. It also means danger and also means wealth. So it's very interesting to say. Okay, between the cultures, it's different. And if we counting the overlap between the dream symbols between the different cultures, we can see the overlap is very, small. It's just less than 18%. Of course, it's maybe not, the most accurate statistics because we cannot never collect all the dream interpretations. But we think it's a meaningful number because we collect a lot of the data. For the Arabic, we mainly collect from books, and for the Western cultures we collect from the Dream Dictionary. For the Chinese, we collect from 周公解梦. It is also a book. So we can see here that for each entries, it does not mean one dream. It's a one dream and its corresponding interpretation pair. So this is a pair is an entry. So that's why we can see more entries than the unique dream symbols, because given the symbol, there's sometimes more interpretations or multiple interpretations. And then we formulate this data set into the four task formulations, including QA, MCQ, and good or bad, and true or false. So good or bad means whether this dream is a good or bad reflection. And true or false, for example, they will ask, I dreamed a snake last night, and someone told me it's means wealth. Do you think it's a true or false? So we have such kind of requests just mimics how humans generally request the models about the dream interpretations. And so here we want to note that for all the questions, we end the instructions like please explain or interpret it from the Western perspective or the Chinese tradition perspective or the Arabic to distinguish the different cultural context. And so this is the evaluation results across the 8 models, and 3 pair of them are the commercial models, and 5 pairs of them are the open source models. Why we say it's pair models because of given a model, we always evaluate both the reasoning and the general purpose. But for the new state-of-art models, for example, from the GPT-5 to the Queen 3, they all were trained within one model but 2 moods. But for other old models like Queen 2.5 and Llama 3.1, it's just these 2 moods are separate models. And then given one pair, we will label the better performance with the color cells. For example, given the GPT-5 this pair, and we will give the yellow color to the Arabic subset and the blue as for the English and the red for the Chinese subset and also the green for the average because we have the 3 subset of the cultures, and but this data set is presented in 2 languages, so that's why we have the 8 columns to represent. And so if this row with more color cells, this means it's a better performance rows. And then we will ask, do reasoning models always outperform the general purpose? And we will see for the old models, the general purpose is better. But for the new state-of-art models, this means the 1 model, 2 moods, and the reasoning moods will be better. Another question is, do Chinese central model like DeepSeek and Queen perform better on the Chinese culture subset like Zhougong dream interpretations? The results is actually no. Queen and DeepSeek do not display significant advantages on the Chinese subset. All the models perform better or perform well in the English and the Chinese culture subset. They all struggle with the Arabic subset. And so we also observed the language variations still impact the old and small models. And so if we look at the Queen 3 1.7 billion as from the model here at the bottom, and they just on the identical MCQ test set they presented for example in the 2 languages for the commercial models and Queen 3 8 billion, they demonstrate strong robustness to the language variations. This means for 2 languages, the results or the performance are similar. But for the smaller and the old models, they have clear disadvantages on the Arabic test set. So this just the larger state-of-art models, they have the specific optimized towards this better multilingual communications. And then we also explore whether different task formulations will reveal the consistent results. And we find for the good or bad and true or false, they mirrors the MCQ trends. And even for this is the free form question answering, and we judge the score using the another model to judge whether they're correct or not. It also consists with the previous other task formulations. And here we also evaluate the settlement of the interpretations from the humans and the models. We can find the AI shows slight positive trends than the humans, but overall it's just a half and half. This also, aligned with our general new natural roles, and good and bad comes at the same time. So does SFT can improve the accuracy? The answer is yes. Specifically, we fine-tuned 5 open-source models for one epoch under 2 settings, LoRa and the full parameter fine-tuning. And so we find actually the full parameter SFT are more effective for the small models, and LoRa is preferable for the larger models. And also, we find this improvement in the Arabic cultures. The yellow cell largely, appears in the column of Arabic and O. This means the Arabic language and the bilingual training data. So this means what? And this means if we want to learn the Arabic cultural nuances, it's easily to be learned by Arabic language or the bilingual. And similarly, if you see the blue cells, it mostly appear in the English column and the O column, the bilingual column. So this means SFT can improve the performance, but optimal configuration differ from the model scaling. And Arabic cultural nuances are easily to be learned by the Arabic language, and similarly for the Western cultures is easily to be learned by the English. And we also gain that current dream interpretation task needs extensive knowledge, memorization, and moderate reasonings. So that's why the new state-of-art models that unifies languages and reasoning at the same model is more suitable to do this task. And models can understand languages, but they lack the cultural nuances. So this just inspires me to think about the relationship between the memorization and the generalization. And I previously checked the interview of Ilya, and he said the real reward hacking is that the human researchers who were too focused on the evaluations. Because of this extensive scaling training, and for example, if we want to evaluate the programming and all the different algorithms and all the different proof techniques are just right at the fingertip of these models. So the models, they don't need to reason. And with such kind of level of preparation, they just need to, memorize, and they don't need to necessarily to generalize to other things. This kind of insights is very similar to an earlier interview of Android. And he also mentioned like the human's poor memory is not a bug, it is a feature. It forces us to generalize and see the forest for the trees. And in contrast, the large language models are distracted by their perfect massive memory, which can hinder the true abstract understanding. So all of this, the insights inspires me to think about, okay, for the future work, how could we, to do like the memory and the generalize. Why like the humans can generalize well with far less data. If we think about the humans, we don't have the boundaries between the pre-training and the post-training. We continuous learning for our whole life. And when we want to new skills, we will memorize less but practice more. Does this mean for the models, they also just need less memorization but more exploration? if we regarding like the entropy loss is for memorization, but RL loss is for exploration or generalize, should we just have more, RL and with more data for RL and less data for entropy loss? There's a recent paper from the NVIDIA in this October. They just included reinforcement learning as a pre-training objective. I believe this might be a very promising direction for the future work to make the model to be more generalized and less, memorize all of things and can recall all at the fingertips. That's all, and thank you everyone for your listening.
All right. Thank you so much for your talk. So we still have some time for discussion, and I'd welcome questions from the audience. So I will receive them in the chat if you send them to the platform. And while we're waiting for questions to come in, maybe I'll start the discussion with a question that I have. So first of all, thank you also for your beautiful reflections at the end and the encouraging words about how perhaps human reasoning and generalization and its limited memory also has some advantages over AI systems that, as we know them at this point. Now, in your first chapter, you talked about our ability to detect AI texts. Now, I think connecting that to the last few remarks you made, perhaps I'm wondering if it would also make sense to look at whether we're able to distinguish AI reasoning from human reasoning, right? So while texts, I guess many of them have factual content, describe situations, our stories, um, but they don't develop thoughts like we do in a math class or something like that, or when presenting ideas. Any thoughts on that? Is that an active area of research?
I think this is a really good idea. Actually, people are doing like they did not distinguish the human reasoning trajectory or the machine trajectory, but they try to label which one is better and to try to use the human reasoning and combine with the machine reasoning trajectories in this RL reward. And so I still think it's a very good strategy to distinguish the human reasoning trajectory and machine reasoning trajectory. This is because it's a concern with the safety. And in a recent study, they find if you given the general or the question to the model or the agents, and the final answer looks very Euro and very general and no risks. But if you check the thinking trajectory, you will find in this thinking process, the model already like have the scamming strategy to cheat us. And it's not their real things. It's just already make the cheat there. So we need to distinguish such kind of reasoning to make the thinking process safer as the last final answers.
Now, of course, that brings us back to the question if we're able to detect those, well, shortcuts or assumptions that the model is making. And I mean, your first part was about detecting whether a text is AI generated or not. In many situations, however, we know that it is AI generated. Like when we're communicating with a large language model, we usually are aware of that situation. Um, but um, do you know, are there any specific features that make us trust those answers? Like you pointed to linguistic features, linguistic style, maybe sometimes flaws in formatting or so that make us realize that this is AI. But is it the same features or other features that make us trust or doubt that the answers we are given are correct?
I think actually it becomes harder, even for what I summarized, the distinguishable cues, like the 6 months ago, it can be easily destroyed by the simple prompting if we instruct a model to avoid these gaps or mitigate these gaps. So I believe in the future, such kind of explicit cues will become less and less. So I think what we can do, maybe we do not care about whether it's a human or machine, but we care about like whether it's safe or not and whether it's factual or not. As long as it's safe and factual, we don't care about its sources or the outcome. So that's
Mhm.
why maybe the retrieval becomes so important recently. We need to retrieve the evidence and give the references to every claim so people can trust. But I think
Mhm.
yes, that's why maybe why it's so important to talk about the trustworthy AI and in the process of AI for good.
Mhm. Now, while we're still accepting questions from the audience, please don't be shy. So I'd like to follow up on that last point of the factual content, which is often the focus, right? Correct, incorrect. Um, but there are contexts in which either there's no real true or false, and I mean some of the last part highlighted some of that, where correctness can be culture specific when it comes to interpreting dreams. But also in our daily life, when we're awake, the same things apply, of course. And so, therefore, what are the risks when AI engages with topics that are traditionally handled by maybe religious authorities or cultural authorities or therapists, maybe even in the context of dreams?
Actually, this is a very good question. And last night, I just dreamed a lot of beans. I don't know why. And there's a one bean is gold. And I think this dream is very, unique. And this morning I just asked ChatGPT, and what does this mean? And the ChatGPT just told me, let me explain from the traditional Western perspectives and the Chinese perspectives. So it just give us the selection to see.
Mhm.
And also after the model explained, I guess this is because the being means the busy. And so the model think I'm too anxious and busy in the current life. And it explained that the gold being means I gained like the value from my work. So the why the bean is gold.
Mhm.
Um, and afterwards, they will continue to clarify, oh, whether you need me to follow up your, current daily life and also your perspectives to further explain for you. So I think for the current such kind of scenarios, the model need to further to clarify what the users needs
Mhm.
and to ask the clarification questions. And then after the users input more context, and we can get what we need.
Okay, okay. But I guess we're not always that lucky that the large language model asks us which perspective to take, and it might
Yes, yes.
use some
So,
default or yeah, uh, preferred or well mainstream or producer biased perspective.
mm.
But yeah, so yeah, I see no questions coming in. So if there's anything else you would like to add, any afterthoughts, I'd like to give you the word again.
So I
But,
really want to just, just encourage us, maybe all our also my students, and to step back and from the previous scaling, pre-training and inference, step back to say, okay, how humans to generalize well, and also even the most easiest things for humans, actually the hardest things for models, and why and to something already embedded in our genes for thousands of years. And so this maybe is very difficult for the models to mimic forever. And we don't know, but let's see. Let's have the embracing attitude for the future.
Mhm. So I guess, and I think that's a positive takeaway message then. Maybe at the end of the day, AI systems and humans will complement each other. We have to learn how to handle them properly and how not to trust them too much. We know that they are overconfident and do not honestly express uncertainties, at least not yet. But we'll learn how to deal with that.
Yeah.
All right. So then, yeah, I think it's time to close the discussion. Thank you so much for your contribution to this discovery series. Thanks to everyone for listening, and hope to see you again soon. Thank you,
See you.
Yusia.
Thank you for all the audience. See you.
Take care. Bye.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.